Hi, my name is Omar. In today's video, we'll be learning about the Accelerometer LED on the Educational Booster Pack MK2. Here is the accelerometer on the MK2, and you'll get to learn how to manipulate the coding on the example to change the color of the LED based on the MK2's movement. In the previous video, the Elkins TIers went ahead and showed you the unboxing video of the MK2 and all of the features of this TI Launchpad add-on. After connecting the MK2 to the Launchpad and then to your computer, you are now ready to code and program. We will now go ahead and open the Energia software. Before we begin, it's important to know what exactly we will be manipulating on the Educational Booster Pack MK2. With that being said, an accelerometer is actually a device that measures minute changes in gravitational acceleration. With this acceleration, it can measure the level of something in relation to the ground and also its user. It has a three-way axis grid, which determines the object's physical position, X, Y, and Z, right here on the top right corner of your educational booster pack. An accelerometer can tell when a device is moved, tilted, or being rotated. The intensity and color of the LED on the MK2 will allow us to see how much the booster pack has been tilted from its origin. Lastly, you are able to mix the RGB colors by tilting the MK2 in a diagonal direction. Now that we know what the accelerometer is and how it works on the MK2, let's start by opening the example on Energia. First, go to File, down to Examples, down to number 9, Educational Booster Pack, and then Accelerometer LED. Click Upload on your top left corner of the window to transfer the coding and make the accelerometer LED actually functional on the booster pack. Upload is your right-hand arrow. On the bottom, you should see Compiling Sketch, Uploading, and Done Uploading. I'd like to take some time to go through the coding on the example so the learner can fully grasp the concept of the accelerometer. So it says on the second paragraph that the sketch demonstrates a complete analog signal chain getting input from the 3-axis accelerometer and using that to mix the color with the RGB LED. If you scroll down, you can see that the accelerometer circuit red LED is attached to digital pin number 39, the green LED is attached to 38, and the blue LED is attached to pin number 37. Also, it can be very important to point out that the X-axis of the accelerometer will be attached to pin number 23, the Y-axis to pin number 24, and the Z-axis to pin number 25. We can now go into more detail of the accelerometer's X, Y, and Z axis. First up, you see the check X-axis. In parentheses, you have the color red. So the first step is we see in green lettering, it says check if tilting on X-axis in positive direction. This means that if you tilt the MK2 to the right or to the positive direction, your output color should be red shaded analog right, in parentheses red LED, comma analog value, and output color. Also, it says check if tilting on X-axis in negative direction. This means that if you tilted the MK2 in the other direction to the left or negative, your analog right color should also be red as your output. Lastly, it says analog right red LED is 0 or off if your X-axis is flat. So if the MK2 is horizontally level, then you should not see a red color. Similarly, like the X-axis, comes check Y-axis. In parentheses, we see the color green. The coding says check if tilting on Y-axis in positive direction. So if you tilt the MK2 upwards, your output color should be green. Stated analog right in parentheses green LED, comma analog value and output color. Also, if you tilt the MK2 in the negative direction for the Y-axis, you should also come up with a green LED color stated right here. Lastly, it says analog right, green LED 0, if your y-axis is flat, stating that if your MK2 is vertically level, then you should not see a green color. Finally, just like the others, comes the z-axis. It says check z-axis, and in parentheses the color blue. This says check if tilting on z-axis in positive direction, your output color should be blue. Also, if you tilt the MK2 in the negative direction of the z-axis, then your output color should also be blue. In the last line of coding, it says if z-axis is flat, then your blue LED should be 0 or off. Some other devices that actually incorporate an accelerometer that you may be familiar with are phones and tablets. The accelerometer on board can allow the screen to change from portrait to landscape just by you turning the phone tablet on its side. Now comes the fun part in which we can actually manipulate the coding. So let's say if we wanted to change X negative into the color purple for the LED light. For the default application, it says check if tilting on x-axis in the negative direction, your color is red. Well, how do you make purple? It's red and blue. So what we have to change is add the color blue to the LED. So you'll copy and paste analog right, red LED all the way to output color. Click copy, press enter, and paste the exact same line of coding below it. This will allow you to have two different colors for the LED. But instead of having two reds, you will now change one to blue. The word analog value here allows you to choose the intensity of the color, anywhere from 0 to 255. So a purple color that has a nice hue that is 100 for red, so let's take out the analog value and write 100. And for blue, you would take out the analog value and put 250. These two colors, 100 of red and 250 of blue, would make a purple output. Another thing that you should do is copy and paste the next line of coding that says analog right, red LED 0, analog value is between 450 and 490, x-axis is flat. This means that if the x-axis is level, then you will not have red color. So you also have to do this for your newly added blue LED. So you do copy, enter, and paste that same line of coding. And also remember to change the second red into blue. You have successfully now changed the X negative color from red to purple. Let's do another example by changing something on the y-axis. Right now, the y-axis in the negative direction has an output color of green. Let's say if we'd like to change that to orange. Well, how do you make orange? Believe it or not, to make the color orange, it's actually a combination of green and red. So we will add another line of coding to have two output colors. So just like the x-axis, you will copy the line of coding, press enter, and paste. This time you will change the second green to red. We should also change the analog value into a combination that will be the best fit for an orange color. 140 is good for green, and for red you should change it to 255, the max that it can be. The last line of coding for the y-axis states that if it is vertically level and the y-axis is flat, then there should be no green color. Now we also have to say that for our newly added red. Go ahead and copy this coding line, press paste, and once again change your second green to red. Now you have successfully changed your Y negative into the color orange. understanding of the MKII, please visit energia.nu and click the References tab. Also, if you have any questions for me, please leave them in the comments section below. Thank you and thanks for watching.